You are listening to The Vocal Technologist. Spoken tech for your ears.
You know, there's a very specific kind of agony that I think only a software engineer can really understand.
Oh boy. I feel like I know where this is going.
I was up late the other night working on this little personal project, right? Just a simple API thing. And for, I don't know, 3 hours straight, every request just failed. 400 bad requests, over and over.
Let me guess. You check the headers. You check the auth token.
I tore the headers apart. I regenerated the token 3 times. I was questioning my sanity, my career choices. I was seriously ready to just go become a goat farmer.
So what was it?
And then I found it. It was a typo, but not even a real typo. It was a 0-width space character.
Oh, no.
One of those invisible characters I must have pasted in from a doc somewhere. I was debugging an invisible enemy for 4 hours.
That is brutal. But it's also, it's the perfect reality check, isn't it?
It really is. Because we spent all this time talking about, artificial general intelligence and quant supremacy, these huge galaxy brain concepts. But half my life is still governed by a missing semicolon or invisible white space.
Or DNS cache that just will not flush.
Exactly. Keeps you humble. We're reaching for the stars, but we're still standing on a pile of shell scripts and rejects.
And that is pretty much the vibe today.
That is the vibe. Welcome back to The Vocal Technologist. It is Tuesday, so we're doing our Tech Tuesday thing, getting into the weeds of web dev and engineering. And today, there's this really strong theme. It's this tension between the massive futuristic scaling of AI and the gritty, low-level reality of how the internet actually works.
It's a total duality. On one hand, you have people talking about prompt architects designing systems that write themselves.
Right.
And on the other, you have someone somewhere needing to know how to patch a C library because one specific packet is eating 50% of the CPU.
Yes. So that's the mission for today. Are we evolving into these high-level architects, or do we still need to know what a packet looks like on the wire?
I think the answer is going to surprise anyone who thinks, coding is dead.
Let's get into it. So first up, the human element. There's been this huge shift lately, this role popping up called the design engineer. And honestly, it feels like we're finally admitting that the old handoff model is just broken.
It's completely broken. Historically, the whole workflow was so linear. You had a designer in Figma, they made something beautiful, and then they just threw it over the wall.
And the dev looks at it and is like, yeah, I can't do that blur effect in CSS without the browser catching fire, and sends back something that looks, well, functional, but soulless.
Right. But the design engineer, that role closes the gap. These are people who don't just spec the design, they actually implement it.
Yeah.
They care about the micro interactions, the polish, the vibe.
Okay, but here's the interesting connection. Why now?
Well, I think the rise of this role is directly correlated to the rise of AI agents.
Because the AI is taking over all the boring stuff.
Exactly. I was looking at Mastra 1.0, that new AI agent for TypeScript. And then you have Townie V5, which is integrated right into your browser.
Right.
These tools, they handle the scaffolding. They write the boilerplate, set up the CRUD endpoints. So if the AI is building the frame of the house, a human value shifts. It shifts to the paint, the decoration, the usability.
So the hard skill of I can write a fetch request is being commoditized. The value is now I can make this fetch request feel instant to the user.
Precisely. The hard skills are becoming table stakes. Which brings us to that insight from January 19th about soft skills. It's just non-negotiable now.
I saw that. It's funny because engineers used to kind of pride themselves on being the grumps in the corner. Don't talk to me, I'm coding.
Yeah, that's over. The AI can write the logic. But the AI cannot navigate the weird political landscape of why the VP of marketing and the VP of product, hate each other.
It's deeper than just politics, though. It's about a concept I've been hearing a lot about, context collapse.
Yeah.
It sounds like a sci-fi disaster movie. But in engineering, we're talking about losing the why, right?
Exactly. Think about it. An AI agent is brilliant at the how. You ask for a React component, gives you a perfect one. But if you unleash that AI on a 10-year-old legacy code base, it panics. It sees a function that looks inefficient and immediately wants to rewrite it.
But it has no idea that the inefficient function is actually a very specific workaround for a browser bug in like Chrome 84 that 5% of your enterprise users are still stuck on.
That is context collapse. The code loses its history. The AI sees bad code. The human historian sees Chesterton's fence, a barrier that was put there for a reason, even if we've forgotten what it was.
I love that reference. Don't tear down a fence until you know why it was built. So developers are becoming guardians of institutional knowledge.
We are the bridge between the raw power of the AI and the messy, illogical reality of business.
Speaking of messy reality, let's pivot from the high-level career talk to the absolute nitty-gritty. Because no matter how smart the AI gets, sometimes you just have to debug a protocol.
Oh, the SSH detective story.
Yes, I loved this.
This is such a classic leaky abstraction problem.
Right, so for anyone who missed it, there's a dev building a game. Not a web game, a game rendered in the terminal running over SSH.
Which is already a wild constraint.
Yeah.
Very cool, but wild.
And they hit this wall. They notice that every single time they press a key, the network usage just spikes.
And we're not talking a small spike.
No, we're talking over 100 packets. For a single keystroke, for a game where you're mashing keys, that's basically a self-inflicted DDoS attack.
It's just terrible for latency.
Yeah.
So they start digging. Is the game loop?
Mm-hmm.
The rendering? Nope. They break out Wireshark, look at the actual packets.
And it's the SSH protocol itself.
It was a feature, not a bug. It was OpenSSH's keystroke timing obfuscation.
That sounds like something out of a spy novel.
It basically is. If you're typing a password over an encrypted line, a smart attacker could theoretically guess the password by analyzing the timing of the packets. Click, pause that, click, click.
So OpenSSH injects fake packets, chaff, to hide the rhythm of your typing.
Exactly. It smooths out the traffic pattern. Amazing for security. An absolute disaster for a real-time game.
So what was the fix?
They had to patch the Go library to specifically disable the ping at OpenSolution.com extension on the server side.
And just like that.
CPU usage drops by 50%. And here's the kicker. An AI probably wouldn't have found that.
No way.
An AI would have told you to optimize your render loop. It wouldn't know to look at a specific extension in the protocol handshake.
It's the difference between driving the car and knowing how the fuel injection system works.
And sometimes, even if you know how the car works, the road itself changes under you. Look at that Cloudflare DNS incident from January 8th.
Okay, this one actually scared me a little bit because it wasn't an outage in the usual sense. It was a correctness issue that broke huge parts of the internet.
A fascinating edge case. So Cloudflare pushes a routine update, and this update totally inadvertently changes the order of records in DNS responses. It put the CNAE records after other records instead of at the top.
Yeah. Now, technically, according to the RFCs, the official rulebooks, the order shouldn't matter. It's just a set of data.
In theory. But in practice, we have Hiram's Law.
With a sufficient number of users of an API, it does not matter what you promise in the contract. All observable behaviors of your system will be depended on by somebody.
Exactly. Even if you say the order's random, if it just happens to be alphabetical for 5 years, someone, somewhere, has written code that will break if it ever changes.
And in this case, that someone was GLIP.
The fundamental C library that runs on basically every Linux machine on the planet.
Wow.
Specifically the getIdrinfo function. That and some very rigid Cisco switch firmware. They were just hard-coded to expect the CNAME first. When it wasn't there, they panicked and assumed the lookup failed.
That is wild. It's a reminder that technically correct is the worst kind of correct if it breaks production.
That's the ugly reality we were talking about. You have to code for the world as it is, not as the manual says it should be.
So we've got human context, protocol mysteries. Let's talk scale. Because some really interesting data came out about how OpenAI actually runs ChatGPT.
Oh yeah, the numbers are staggering.
We're talking 800 million users. Can you even imagine the database load? Every prompt, every regeneration, scrolling back through history. How are the servers not just melting?
Well, they have a few. They're on Azure PostgreSQL, but the architecture is very specific to their workload. It's predominantly read-heavy.
Which makes sense. You write a prompt once, but you might read the answer 10 times.
Right. So to handle that, they have a single primary instance for all the writes, but they have nearly 50 global read replicas.
50, that's huge. But that creates its own nightmare, right? Replication lag.
A huge nightmare.
Yeah.
Imagine you type a prompt, it saves to the primary in Virginia, but you're reading from a replica in Tokyo. If that data hasn't replicated yet, your chat history just looks empty.
The read after write consistency problem.
Exactly. And for stuff that doesn't fit a relational model, like logs or vector data, they offload that to sharded systems like Azure Cosmos DB.
So it's the right tool for the right job. They aren't trying to force one database to do everything.
At that scale, you can't. Generic solutions just fall over. You have to specialize.
Speaking of specialization, did you see that chart GPU stuff?
Yes, this is so cool.
As a data viz nerd, I love this. We've all been there. You try to render like 10,000 points in a browser with DOM elements or SVG, and your laptop fan tries to achieve liftoff.
The DOM is just too heavy. It's a document model. But ChartGPU uses WebGPU. It's bypassing the browser's normal rendering loop and talking more or less directly to the graphics card.
We're treating financial charts like they're a AAA video game.
We basically are, and it lets you render millions of data points with smooth zooming and panning at 60 frames per second. It's a total paradigm shift.
It's amazing how much optimization is just stripping away overhead. Which brings me to my favorite boring story of the week.
The Python packaging library.
Yes, the unsung heroism of open source.
It really is.
So for context, this library is used by pip, which means every single time any Python developer on Earth installs a package, this code runs.
It is critical infrastructure, and some devs profiled it and found that parsing version numbers was slow.
So what do? Rewrite it in Rust? Use AI?
Nope. They optimized the regular expressions.
It's always rejects.
It's always rejects. They found the rejects was backtracking too much, and they were creating all these redundant objects in memory. Clean up the rejects, remove the object creation, and boom.
What was the speed up?
3 to 5 times faster.
That's massive. If you speed up pip by that much, you are collectively saving the world's developers thousands of hours of just waiting for progress bars.
And it wasn't glamorous work, but the impact is arguably bigger than any flashy AI demo this week.
That transitions perfectly into tools, because sometimes the best tool isn't the shiny new thing. Sometimes it's a command from 2005. I have to evangelize git bisect.
Git bisect is a superpower that too many developers forget they have.
I feel like a wizard when I use it, but it's just binary search.
It is. Instead of manually checking out one commit, testing then another, you just tell Git, this commit here is good and this commit is bad.
And Git just splits the difference. It checks out the middle commit. You test it. Bad. It splits the remaining history in half. You keep doing that until it pinpoints the exact commit that introduced the bug.
It's invaluable. And honestly, in the era we're entering, where an AI might generate 500 lines of code in a single pull request, tools like Git bisect become critical.
Why do you say that?
Because when a human writes a bug, it's usually logical. When an AI writes a bug, it could be a weird, subtle hallucination buried in a huge block of boilerplate. Finding that needle in a haystack requires a binary search.
That makes a lot of sense. But wait, I want to touch on something you said earlier about ugly reality. There was a defense of ugly code going around that I found really provocative.
Ah, yes. The contrarian view.
Yeah.
And frankly, I kind of agree with it.
You agree with it. But aren't we supposed to worship at the altar of clean code?
Clean code is great for textbooks. But in the real world, ugly code is often just code that has survived.
What do you mean by that?
You see a massive function with nested if statements and weird flags. Your first thought is, this is ugly. But those flags, they handle the edge cases. They handle the user with the weird character encoding or the network timeout.
So ugly often just means battle tested.
Exactly. And there's a business angle to it too, something called revenue debt.
Revenue debt, I like that. It sounds much better than technical debt.
Technical debt sounds like laziness. Revenue debt acknowledges the trade-off. You wrote that ugly hack to ship the feature on Friday and close $1 million deal.
The code is ugly, but the check cleared.
Right. The problem isn't the debt itself, it's never paying it back. But acknowledging that ugly code often serves a vital business purpose. That's a maturity milestone for an engineer.
True. Although I will say, there's ugly because it handles edge cases, and there's ugly because I didn't sleep. We got to know the difference.
Very true.
Okay, before we wrap up, I want to look a bit further forward. There are some concepts popping up that feel very next gen. Have you dug into this social file system idea?
This is a really interesting paradigm shift. It's getting some traction with things like the AT protocol and decentralized identifiers, or DIDs.
So break it down for me. What is a social file system?
Well, think about how your digital life is structured now. Your photos are on Instagram, your thoughts are on X, your professional life, LinkedIn. They're all data silos.
Right. If Instagram shuts down, I lose my photos. If I get banned from X, I lose my followers.
The social file system flips that. Imagine you have an everything folder, a repository that you own.
Okay, so like a hard drive in the cloud that I control?
Exactly. And you grant apps permission to read from it. So instead of uploading a photo to Instagram, you put the photo to your folder and you give Instagram permission to display it. If you get bored of Instagram, you revoke their access and grant it to a new app.
That sounds incredibly liberating. The data becomes host agnostic. But it also sounds like a nightmare for the tech giants. Their whole business model is trapping my data.
But it completely disrupts their moat. That's why it'll be a hard battle. But the tech is being built. DIDs give you an identity that isn't tied to a server. It's early, But decoupling identity and data from the application is the next frontier.
I really hope that takes off. On a lighter note, did you see the optical illusions in CSS?
This is the fun side of the web.
People are coding over 50 different optical illusions using only CSS and HTML. No JavaScript.
It's just a testament to how powerful the rendering engines have become. You can manipulate geometry, perspective, gradients. You can literally trick the human brain just by stacking divs.
It's just cool. It reminds you that the web is a creative canvas, not just a way to serve JSON to a React component.
Absolutely. It brings the joy back.
Okay, we've covered a lot. Design engineers, SSH mysteries, scaling Postgres, the philosophy of ugly code. But I want to leave everyone with a final thought. We touched on AI productivity earlier.
And this brings us to the provocative thought for the day. There's a growing concern about what some are calling agent psychosis, or more bluntly, slop.
Slop is definitely not a word you want associated with your production code.
No. But consider this. Recent tests show AI coding tools often generate 2 to 6 times more code than a human to solve the same problem. They add defensive patterns you don't need, verbose logic, just fluff.
So we aren't just getting help, we're getting inflated.
We are inflating the code base. And if code review becomes the bottleneck, because humans can't read code as fast as AIs can write it, we have a huge problem. We might be building unmaintainable monsters.
It raises a big question about how we even measure productivity.
Exactly. If an AI writes 1,000 lines of code in a minute, is that productive? Or did it just create a maintenance nightmare for the year 2027? I think the definition of a senior engineer is going to shift. It won't be how many lines can you write.
It'll be what?
It'll be how many lines can you delete.
Productivity measured in lines deleted? I love that. Less is more, especially when you're the one debugging it at 3 a.m.
Precisely. Keep it simple.
Well, on that note, I'm going to go stare at my own ugly code, run git bisect, and maybe delete as much of it as possible.
Sounds like a solid plan.
Thank you all for tuning in. This has been The Vocal Technologist. Keep your commits clean and your packets low.
See you next time.
Spoken Tech for your ears.